Title: Missile Range Extension Technology, Glide Wing Application Method. One effective way to increase a missile's range is to equip it with glide wings. This method is operated in 3 phases: launch, mid-flight, and terminal approach to the target. 1. Launch phase. At the time of launch, the glide wings remain folded. In this state, the rocket engine provides the initial thrust to bring the missile to the required altitude and speed. 2. Mid-flight glide phase. When the missile reaches a certain distance and altitude, the rocket engine output is reduced to a minimum or shut down, and the glide wings are deployed. This allows the missile to utilize aerodynamic lift for long-distance gliding flight. In this process, fuel consumption is reduced, and the flight distance can be greatly increased. 3. Target approach phase. When the missile closes in to within several tens of kilometers of the enemy target, the glide wings are folded again, and the rocket engine is run at maximum power. This accelerates the missile to supersonic speed to strike the target. This technology is particularly effective when applied to anti-ship missiles. This is because, to attack enemy warships at long range, it is more advantageous to use a large number of small and medium-sized missiles than to rely solely on large missiles. For example, large missiles can only be used on large warships. So if such a ship is sunk, no more large, long-range anti-ship missiles can be launched. However, by using small and medium-sized anti-ship missiles, they can be launched from various platforms such as fast attack craft, thereby improving the survivability of friendly anti-ship capabilities. If artificial intelligence is incorporated, it can determine the optimal timing for adjusting rocket engine output and deploying or folding the glide wings. This could be described as turning the missile into a robot.